Hello, I'm Jeremy Terrell from UNC Wilmington, and we're going to be talking about mapping incoming students or visualizing the geographical distribution of a student population. Particularly, we're going to be looking at majors or graduate students, but it could be really any population. My website is located at jterrell.com. If you have any questions or anything, you can go there and use the contact information to get a hold of me. I'm happy to discuss these issues further. All right, so like anything else, we want to think about rhetorically what we're trying to achieve with what we're doing here. This particular strategy is probably going to be more useful internally or institutionally. Finding out where our students are originating will tell us something about our recruitment, our appeal, that sort of thing. And that is the common language of the institution now. These sorts of metrics are increasingly important beyond the department level or the individual level, and they will only continue to be so, I would think. So internally, knowing something about incoming student populations geographically, I think, is valuable. You could demonstrate the geographical scope of your recruitment, right? You're able to pull students from a large national, international body. Or conversely, you can demonstrate service to a local population. I'm at a state institution, and part of our charter is serving the state student population. So this could demonstrate how that's working at the department major level or graduate students or something like that. Externally, for new recruitment of students, probably this information in this strategy is limited. Incoming potential students may not really be that interested in geographically where other students are originating. And also just rhetorically, it seems like sort of an odd appeal. Come to our program, we do or don't serve the local community or something like that. I think for recruitment purposes, outgoing student data, so placement of graduates, that's going to be a much stronger recruitment tool, and we're going to talk about that in a different tutorial. But this incoming student data, that's probably going to be more useful internally. So in terms of the things we're actually generating, the products we're making, these can be print items, either individual images or small multiples, a sequence of images that construct a particular narrative. That's what's going on in the poster that accompanies this tutorial. However, because of the tools we're using, we're going to be generating screen resolution images. So they're not going to be ideal for printing unless you're dealing with small multiples, because then, of course, you can scale down the physical size and then scale up the resolution and not lose too much. Excuse me. But print is possible for what we're doing. Electronically, there are some options we have, and electronic work may be a better way to sort of leverage what we're dealing with. We can look at interactive maps. Let me just pull up some examples here. Yeah, here. So this, for example, is just a static image. You can produce these for print or for electronic use. This is an individual year. Here's an aggregate. This is an interactive map. When embedded, you'll notice you can mouse over states and get state-level data. That's obviously not going to translate directly to print. You can also do something like an animation. So we're going to look at a simple animated GIF. Let me pull up one of those. And here you can see this is in a way similar to a small multiple in that it's showing a sequence of data to suggest a narrative. Here, that is imposed, we could say, by the animation itself, right? So the earliest year is 04, the latest is 14. If we look at the narrative here in 04, the pool is geographically localized, and then it spreads out as the years pass by, and then the aggregate looks something like this. So those are the kind of things we're going to be constructing. Let me just pop back into my slideware here. Those are going to be useful for different rhetorical ends. As I mentioned, we're going to be dealing with in terms of tools and products. They're a little more focused towards electronic use. If for no other reason, then they're going to be screen resolution. And also the kind of data, it just seems to be more communicative when it's in something like an animated sequence, when you're able to interactively look at the state level, that kind of thing. So data collection, hopefully this kind of data is something that's going to be available to you, either from your institution itself, our registrar or whatever other entity controls registration. They should have that kind of data. You may not be able to get it directly. You may have to go through a department chair or something like that, but you should have this kind of geographical data. If you don't get it directly from the registrar or another institutional entity, you should have something like mailing addresses for your majors or your graduate students or that kind of thing. So you could compile this yourself. Hopefully you won't have to, but it should be there. This is just a reminder to anonymize this kind of data. Things that are going to be coming from something like the registrar could have a lot more data than we need, and anything that's superfluous is, a potential for leak. So that means cleaning out. We don't even need names at all. We really just need state counts. We don't need fine-grained location data. So if we were to harvest this from mailing addresses, really all you'd need is the state, right? We don't need their actual address, and you wouldn't want that accidentally getting shared. So that's just a reminder to anonymize. Since we're just dealing with states and counts, that's really all you need. As I mentioned, we're going to be dealing with some electronic tools. Specifically, we're going to walk through Google Spreadsheets and its map chart feature. That's the most straightforward way, if you're dealing at sort of the state level, to do something like this. It doesn't drill down further than that. So if you're looking at county data, this wouldn't be a fantastic tool. And you may want to do that if you're a state institution and you're looking at, how you're serving urban counties, rural counties. In my state, North Carolina, we have sort of 3 distinct geographical regions: the mountains, the Piedmont, and the coast. So that kind of data might be useful, actually. This particular tool isn't going to be great for that. There are other tools that do that, and some of the other tools we'll look at in other tutorials are actually better for that kind of thing. But this one isn't. It's just a little too large-grained for that. All right, that's the gist of what's going to be going on here. As I mentioned, I have my data just came from essentially our registrar, or at least it's available through them. This is actually test data. I received our data, but I just made example data because I didn't want anything being shared in this kind of public format that could potentially be legitimate, potentially be traced back to an individual student or anything like that. So this is completely invented test data predicated on sort of the format that I received from our institution. All I've retained is first names, and again, these are invented, and then states, a sort of plausible distribution of incoming students. This totals column actually wasn't there. I added that. I received this as an Excel file. That's not surprising. Probably data you receive from your institution will be in Excel, or maybe CSV, something like that. Probably Excel, let's be honest. I'm just going to import this into my Google Drive. Whoops, wrong one. Let me pull that up. And we don't need these right now. So this is my Google Drive. This used to be Google Docs. I think that language has been basically retired because Google Drive encompasses documents, spreadsheets, images, maps, fusion tables. So that's just sort of the umbrella term now. I'm just going to go ahead and upload that spreadsheet. And it's going to stay in Excel format. But if I do open with Google Sheets, it'll actually convert it for me. Excuse me. You can see if we go back to my drive, it's actually both retained the original file and converted a Google Spreadsheets version. That's what we're going to be working with. Now we have a year-by-year breakdown here. You may not have that. You may have to collect those individually. you may not have it at all, in which case you just start now and then move forward. As I said, I think it's a fair statement to say that this is the language of the institution, these kinds of metrics. So it's important to start collecting this if you don't have it already. Excuse me. So this is going to be pretty straightforward, this process actually, because Google Spreadsheets has a built-in map chart. We're not going to have to do a lot of fiddly converting. We won't have to move it to Google Maps or anything like that. The drawback is it really only works the state level. So here we have students ostensibly arranged by last name, although that column has been deleted by me to make this anonymous, and this is invented data anyway. I'm not going to delete their first names yet, just because I might be using this data for something else. But we don't need them. Really, all we need are state counts. We obviously don't want to go through here and count them manually because that introduces the possibility for student error, or excuse me, for human error. Oh man, what a Freudian slip. I always try and pull the human elements out of things like counts. I mean, that's what computers are for, right? So let's just go ahead and make this in a digestible format for computers. So I'm just going to sort this data. Sorry, I've been speaking a little bit more than usual today. We'll just do a sort range here. It does have a header row, obviously, first name, state, totals. We actually want to sort by state, and put it alphabetically. So now we just need the actual counts of these states, and there's lots of ways to do that. The one I wouldn't do is just go through and manually count them. Obviously, for some of these, like Alabama and Arizona, it's self-evident, it's one. But some of these, it's a little more ambiguous, right? North Carolina, I don't know offhand what this is. So there's different ways to get these counts. As I mentioned, I usually think it's a good idea to sort of get human counting out of the formula, because it just introduces the possibility for additional errors. And those are really tricky ones to track down. So there are lots of things you could do. You could just select cells, and we can see down here under count, it automatically shows you the count of cells with data. So you'll notice it keeps counting up even though these are different states, because it's just reporting how many cells have values in them. So if we're doing that, it's certainly something we could do, right? If we wanted to count Kentucky, we can just go down for all of Kentucky's. We've got 4. We can just press the right arrow and hit 4. The one advantage to that method, or one advantage, not the only one, is that it gives us a hard value here. 4 is actually inputted into the sheet. There are other options. We could use something like a count A function, right? I'm going to do equals and count, and it's going to give me count A, which is it just counts the number of values in a data set, whatever they are. So if I select that and then just select this range, it'll give me 4. The thing about functions, of course, is if we're going to be compiling these into an aggregate or something like that, you always have to be a little bit careful manipulating functions, because this is not a hard-coded value. So if you're copying and pasting, it's not going to report that unless you specifically tell it to report the value, and you may or may not want to do that. So it's kind of up to you. The process I'm going to be using, I'm not going to be putting in all these count A's because I don't have that much data. It would be a little bit of overkill. If I were dealing with more data, I probably would use count A, because then I'm not doing any counting myself. It removes me from the equation. But because we're dealing with fairly brief sheets here, I'm just going to be selecting like this. I can see my count down here is 2. I'm just going to move over, hit 2, and I'm going to go like that. Iowa, we've got 2. Kentucky, we've got 4. This is tedium, but it's also mercifully short. 16. Ohio, it's going to be 3. And I'm just continuing in this process, even though I can tell that that's 2 and that's 4. So there we have our count. Our next step is to collect these counts together. You can actually keep them spread out, but for what we're doing, it's going to make more sense to have these compiled. What I'm going to go ahead and do is I am going to, do I want to delete this column or just hide it? For the time being, I'm going to hide it. No, I'm going to delete it. I'm going to delete this column. I don't need it. It's anonymous data. I just want the state counts. I just cleared it. I'm going to actually delete it out there. So now I want to pull these state counts together. That also will give me useful data in terms of, what's the most, what's the second most, that kind of thing. So I'm just going to do a second sort here. I do have a header row, so I'm going to do it by totals. I'm going to go in descending order because I would like to see what's most. I know what it is, but I'd like to see sort of how the rank is. And I can get rid of the rest of these because they are just duplicates, right? These are things I've already counted. I'm just going to clear that rather than delete it. So now we have a count of our states, and I can see sort of a rank. Excuse me. The next step, the map chart itself, it's quite easy. We just have to go to Insert Chart. We'll go to Charts here and select Map. There are two options here. We really don't want, for this purpose, a geochart because we're dealing with state-by-state counts, right? If we zoom in on that, this doesn't really give us what we want. I mean, it's just sort of finding the arbitrary, well, not arbitrary, it's finding the geographical center of states and telling us the values there. But that's not really what we want to see. What we want to see is what it calls a geochart. Sometimes this is a choropleth, a state-by-state heat map, something like that. That's what we want. We do want to go to Customize here because by default, it gives it this interesting Christmas-like coloration. That's always been a little interesting to me, using two different colors for something that's the same value, right? This is the same value. It's just count of students from that state. So really, we should have the same color and then just vary that, right? Because it's the same. Axis. So color should reflect that. So I'm going to set my min here as just this light red, my mid as this mid red, and then my max as this dark red. And now this makes sense, right? It's one color. We know at a glance, well, this is going to be the greatest concentration. These lighter ones are going to be the least concentration. The default no value is gray, which I think is good because it helps it stand out from the background. That's pretty much it. Click Insert. It automatically will pop it on the same sheet. You can move this into its own sheet if you like. I'm going to leave it here because I'm going to be doing multiple ones. So at this stage, there are a couple of things we can do. We could do Save Image. Now, as I mentioned, it's going to be exporting it in PNG format. I just downloaded it. And it's basically just a screen resolution PNG. So it's not going to be great to print out. And even if you move this into its own sheet and print, it's still dealing with the same. It's still rasterizing that image. It's because this is a chart, it's not really a map. You're always going to be dealing with sort of screen resolution stuff. Sorry about my voice skip there. But if we're ultimately dealing with print, that's what we do. I would suggest something like a small multiple so that you can scale down the physical size, the physical dimensions, scale up that resolution, and then it won't be too bad. I mean, it's a little bit of a hedge, of a cheat, but it's a way to go. If we want this electronically, we can, of course, just save the image, and then we have it electronically, and it's screen res, so everything's fine. We do want to look at a couple of things, though. If we wanted to embed this in a web page, we can certainly do that by publishing the chart. If I do this, notice that it doesn't automatically give us a link because right now this spreadsheet is private. It's not shared, right? So I'm going to have to do that. I'm going to have to publish it publicly before I can do that. There we go. I've got this link now, and let me just show you what that looks like. So there it is. And you can see when I mouse over, I get the values. It gives me some options here if I want it as an image or if I want it interactive. Right now, that is what I want. Okay, and you can see now I've published this. The sheet itself is still mine. We can look at the sharing for the sheet here. You can see that I've retained permissions for me. The sheet is still private, but this visualization has been shared. So that's that. The other thing we did want to look at is assembling these into an aggregate or going year by year, as I've got data for here, and then producing a static image for each one. Right, so I've just saved the image for each one of these, or that's what I would do. I've done it in advance, obviously. And then what we can do is build a animated GIF. There are several tools which will build animated GIFs, but fortunately there are also a bunch of online services that'll do it for us. The quirk of it is, if it's an online free service, they're probably going to want to put a watermark or something like that on there. But if you poke around, you can find some that don't tinker with your image. I used gifmaker.me. As I said, I, in advance, went ahead and produced a chart for each year of data. I went through the same sequence through each year. So I have 11 of those, I guess. Let me just pull up this. So here's my sequence. It'll go ahead and upload those. We can change the order, although because I named them by year, it's going to do that automatically. We can change the dimensions. I'm going to leave that as it is in its native size. We can see a glimpse of the animation speed. Now, 500 milliseconds, that's pretty quick. We can see up here. I'm going to go ahead and put that at a second, 1,000 milliseconds. We can see the frames move a second at a time. We'll leave it on infinite repeating. We don't need music, which isn't really part of the GIF spec. And then it has create frame animation, create GIF animation, create video animation. I just want the animated GIF. So it'll compile those together, give me these options. I can download it, and I can also just view it online here. So that's what it looks like. I should now also on my desktop have, there it is, an animated GIF. I'm just going to open this with, well, not Explorer, with Chrome. And we can see there's no watermark. So we could embed this GIF on a page. We can use this as a dashboard to provide information. I mean, ultimately, our rhetorical purpose is probably going to be telling some kind of story, either inside our department or outside of our department, some sort of narrative about recruitment and how that's working out, where our majors or graduate students are coming from. So that's the basics of how this functions. And as I said, this is probably a narrative that's more appropriate to an internal audience. I'm not sure this kind of information is going to be great for recruitment purposes. Placement of recruits is probably going to be more relevant to potential students. So we'll be looking at that in a different tutorial. That's it. If you have any questions, please feel free to contact me. The best way is probably just to go to my website here, jtyrrell.com. There's contact information there, and I am happy to answer any questions you have. All right, thanks a lot. I will see you again.